Okay, so this is an explainer for question 3 on the winter 2019 paper. Okay, first question is about heating. I do encourage you always to look at the diagram, okay, because they do deliberately kind of try and persuade some answers out of you guys. Okay, we've got our potato here being cooked using a metal skewer and a heating element. Okay, we're told here that the air in the oven is heated by the heating element. And what you should know is that when you heat air, the air gets less dense. Okay, so what we're expecting is, remember to draw an arrow. This is something that a lot of students forget to do. Yeah, and that should show that my heat is causing the air to move up. So any arrow pointing up is going to be sufficient here. You're then asked to name the main method of thermal energy transfer. I want to remind you at this point that there are 3 methods of thermal energy transfer. One of them is conduction, one of them is convection, and one of them is radiation. In this case, we are doing convection. So I'm just going to score out conduction, I'm going to score out radiation. We're doing convection here. And that's because our heat is being transferred by the moving air. You'll remember this idea of convection currents, which is where if I heat air, the hot air rises. This is hot air. And then the cold air comes down to replace it. And this is what we called our convection current. Okay, this is our convection current. Okay. We then need to go on and describe the process of conduction in a solid, and it's very important that you are focusing on the point made here. As we know, conduction, the best conductors are metals, and the way that they conduct is if we've got our atoms here, and then our delocalized electron here. What that delocalized electron does here is, if I'm heating something, I have heat at the bottom here, then what the electron will do is it will gain a lot of energy and it will move up away from the heat and therefore carry the heat from the hot to the cold end. Now notice my explanation there has nothing to do with particle vibration, which is the key word there. Okay, so you need to think actually about the difference process. You should be aware that each of these particles, as we heat it, they will start to vibrate left and right. And as a result of this one vibrating left and right, the next one will vibrate, the next one will vibrate, and so on and so on. This is a slower process than our electron transfer, very slow, but it is also another way of passing heat energy through a solid. So as the solid is heated, the particles gain more energy and they start to vibrate more. Notice I'm talking about vibrations here. And again, that vibration passes from a particle to its neighbor and therefore spreads through the solid. Make sure you are referring to what they are asking for in the question. Okay, let's just go on to the next part of the question. Quite a big one here. Okay, we've got 4 electric hot plates, A, B, C, and D. Okay, they're each connected in parallel. Okay, very key term here. And each hot plate is operated by a separate switch. You can see here that I can turn them on independently of one another. First thing to do is to talk about the resistance of hot plates A and B. Okay, so notice we're not thinking about A, B, C, and D. Yeah, we are thinking about A and B only. Remember, they're connected in parallel. So we need to use our formula 1 over RT. We've got RA and RB. We know RA and RB are both 60 ohms. It's a very good idea in some way to highlight or circle something just so you know you've registered that number. 1 over 60 plus 1 over 60 is 2 over 60. And then remembering that what we've done in that is calculated 1 over RT, not RT, not the total resistance. We need to then flip that number to get the total resistance, which is our 30 ohms. Remember that whenever you're doing this, by connecting in parallel, we reduce the resistance. As such, your number here should always be lower than the resistance of these individual guys. So in this case, it should be lower than 60. If you look at A, B, and then C and D, well, the situation is exactly the same, so they should have the same resistance, which is why this answer here is 30. Now, in an exam, if you have to be careful here, you must make sure that these numbers are the same. Okay? And because they've given you this, there's no real out. This answer can only be 30. Okay? Last point here. Okay, this is a big question. This one, 11 marks, lots of different bits. I'm going to hope that everyone here is able to remember the boiling point of water. That is a gimme, this answer. But a slightly harder question is this description one here. Now, again, I think you should got to get used to reading the question. Notice here they've got three things that they want us to talk about: forces, distances, and motion. We then look at the number of marks, and there's 3 there. So a good bet here is if I couldn't give a statement about each of those, then I probably am going to be onto a winner here. Okay? Describe the differences in liquid, water, and steam in terms of these things. Well, we know that if we go from a liquid, we've got those particles which are close together, yeah, but able to move past each other. So there's space in here, not quite as tightly packed as our solid, but close together nonetheless. If we go to the gas, then we're talking about particles very far apart and moving around freely. And so really we've kind of, as long as this picture gives us a lot of the answers here. 1, the forces of attraction between the molecules are far greater in the liquid than in the gas. Well, they're close together, yeah, in the liquid, and so therefore the forces are going to be bigger. The molecules are much further apart in the gas state than in the liquid state. Yeah? And then finally, our gas molecules move freely. Do you notice that they're all really linked together? We have free movement because the molecules are further apart because the forces are lower. In the question, they've really given us a bit of a signpost as to what they want here. So if you can give 3 coherent statements to that effect, then you're doing very well.